Hello and welcome to the 2012 SUAS competition. Zos Brooks is my name, and here at Webster Field in Maryland today, flying robots are the game. SUAS stands for Student Unmanned Air Systems. You can also call them UAVs, robots, or drones, but no matter what you call them, the goal is the same: to autonomously fly a challenging surveillance course in order to win barrels of cash. These all-student teams can build their bots out of anything that flies, and we have planes, helicopters, and quadrotors represented this year, some coming internationally from India, Turkey, and Canada, as well as the United States. This year is the 10th annual competition. It's sponsored by AUVSI Foundation, PEOUNW, and ONR, and we have some amazing aircraft here, so there's going to be plenty of excitement both up in the air and down here on the ground.
There's actually 3 phases in the competition. The first phase is a journal paper. That's worth 25% of the points. And then they have to do a test-ready brief to show that they're ready to fly when they get here, and that's worth 25. And then the other 50% of the competition is the actual flying portion.
The idea behind the competition is to fly designated waypoint tracks, to look for certain targets along the tracks, and then the track takes them into a search area where they search for additional targets that are just generally laid out.
The robot needs to accumulate data on its sensors and then use artificial intelligence techniques to make decisions based on that data to navigate the course without any human control.
Well, you came here and you can look at all the great airplanes and great team that we're competing against, and it's just fantastic to see the ideas that comes up and all the different concepts that can come out from a single mission requirement.
It takes a lot of time, it takes a lot of patience, it takes a lot of motivation, and there are mishaps, of course. It's flight testing, that's just the way it goes, but you learn from your mistakes and just get better at it.
We came in pretty much nose first and obliterated the airframe. We saved one wing, I think.
That's always a risk when you're putting a robot in the air, right?
Yeah, we're usually hoping for the best, but you know, it happens.
It's a diverse field this year in every respect. We've got high schools mixing it up with universities and colleges, and all experience levels are represented.
As a high school team, mostly it's a learning experience for all of us because we get to see what we're coming into. But when you see the college level, you see what we have to look forward to, so it's really cool.
Thinking ahead, it's really nice to get to see what you'll be like in the next 4 years and meet people that are in your shoes 5 years down the road. It makes you realize what you're capable of.
Classroom, it's all numbers and stuff. Here it's actually putting it to use. I feel I learn a lot more here doing this competition than I do in classroom. And I'm hoping to take everything I learn here into getting a job and doing well there.
It's great for the career path, honestly. I mean, you can go around and tell people that you've actually done something. It's a big hands-on project. It's not something where you just sit down and do your homework and you get the A in the class. It's really about accomplishing something.
They're learning to design these aircraft, to program their systems, to build mission operator stations, and all that talent is what the government and industry is looking for the future. A lot of these students actually get hired out of the competition, and they're very talented, and we're mining that talent. That's kind of what we designed it for.